Jhanine L, and today I am here to give you a quick bite for the highlights of Medium Access Protocol, the IEEE 802 LAN standard, the network layer, and the Internet Protocol. Okay, so let's begin with Medium Access Protocol.
A network may be composed of point-to-point stations, or it may be composed of stations sharing a single channel or communication medium. For networks of the latter type, there must be a scheme that should govern as how the channel can be allotted to all stations. These schemes are called medium access protocols. Medium access protocols can be grouped into 4 techniques: fixed assignment, random access, demand assignment, and mixed strategies. The fixed assignment techniques allocated the channel in a static manner. This allocation scheme does not depend on the demands of the station and is therefore inflexible. Schemes that fall under these are: first, FDMA or Frequency Division Multiple Access, where each station is allotted a frequency for it to use. Next is TDMA, Time Domain Multiple Access, where each station is allotted a time to use the channel. Last is CDMA or Code Division Multiple Access, where each station has its own frequency hopping pattern. The next technique is random access techniques. Random access techniques allocate the channel to stations that need it randomly. The earliest example of this is pure Aloha. In Aloha, station transmits every time even if other stations are using the channel. It is grossly inefficient since stations transmit indiscriminately, resulting in frequent collisions. This can be improved by dividing the channel time into slots where station can transmit only the start of a PIP signal. This is called slotted Aloha. The efficiency of pure Aloha can be improved by allowing stations to sense the channel first before transmitting, thus minimizing collisions whenever the channel is being used. This scheme is called CSMA or Carrier Sense Multiple Access. CSMA can still be made more efficient by truncating collisions resulting in lesser wasted bandwidth. We can further improve the CSMA performance. To do this, we can lessen the wasted time whenever there is a collision. Remember that a collision garbles the data on the channel and its duration is equivalent to the length of one packet. If transmitting station will immediately abort their transmission, a fraction of a second can be recovered. Thus, with lesser time wasted on useless transmission, the channel utilization will increase. This scheme is called CSMA-CD or Carrier Sense Multiple Access with Collision Detection. This is an important technique, as you shall see later in the next part of the discussion when we discuss one standard, the IEEE 802.3, which work on this fashion. The third technique is demand assignment technique. Demand assignment techniques allocate the channel based on the requirements of the station contending for the channel. Demand assignment techniques fall in one of 2 categories: those with a central controller and those with distributed control. Central controlled. This subgroup of demand assignment-based techniques requires the use of central controller, which shall allocate the channel to requesting machine. Polling systems. A central controller may be assigned with the task of polling each station, prompting those with field queue to transmit. Polling is efficient if, first, the round-trip propagation delay is small. Next is the polling message overhead is low. Circuit-oriented system. Another protocol using central controller allocated FDMA or TDMA slots to requesting stations. The second category, where the control is distributed, requires all stations to execute the same algorithm for coordinating medium access. 3 examples that fall under these schemes are all variants of slotted Aloha, namely: first, reservation Aloha. Next is round-robin reservation scheme. And last is first in first out reservation scheme. Reservation Aloha allows station to access the channel using slotted Aloha. Once a station has acquired the channel, that slot will be reserved for the same station on the next round. Next is round-robin reservation scheme. uses TDMA channel assignment, but unused slots are given to achieve stations or stations with filled queues. The last is first in, first out reservation scheme. It allows station to reserve a slot before any data can be transmitted. In this scheme, the channel is divided into two kinds of slots, data and reservation slots. The data slots are free of conflict because it is used on a reservation basis, while a reservation slot is divided into V small sub-slots, which are used for the transmission of reservation packets. We are moving now to the last technique, which is the mixed strategies. Adaptive strategies and mixed mode techniques adapt to varying needs of the station by implementing techniques that are combination of what I mentioned earlier. One example of this is satellite system that uses slotted aloha for uplink and TDMA for downlink. Another example is the reservation abandon collision, wherein station access the channel like slotted aloha, but when a collision is encountered, the channel is allocated based on the reservation made by colliding stations. Now that you are familiar on the medium access protocols, we will now proceed to the details of the IEEE 802 LAN standards. First, we have IEEE 802.3 CSMA CD and Ethernet. The IEEE 802.3 standard specifies a family of bus network operating in a moderate geographic site. The medium is accessed using carrier-sense multiple access with collision detection or CSMA-CD protocol. If a collision occurs, the colliding station executes the binary potential backoff algorithm. From the CSMA-CD model, we can identify three possible states of the bus. These are idle, collision, and valid transmission. The channel is idle if no station is transmitting. It is under collision or contention whenever there are two or more stations transmitting at the same time. And lastly, the channel carries a valid frame when there is no other packet except one. Let's talk about now the IEEE 802.3 physical layer specifications. The standard starts at the speed of 10 Mbps per baseline signals. The maximum cable length depends on the wire type. Stations transmit frames using a specific format, which contains the Ethernet address of the source and destination stations, error detecting codes, and the data and the other overheads like padding, preamble, frame length field, and setting delimiter. The convention used in naming the specs are based on this format. The data rate in Mbps. Next to that is medium type or signaling technique, and then followed by maximum segment length. For example, we have 10 base 5. The data rate in Mbps will be 10 Mbps. The medium type or signaling technique, which is base, will be baseband. Then the maximum segment length will be 500 meters. The three most popular flavors of IEEE 802.3 are 10 base 5, 10 base 2, and 10 base T. The IEEE set the minimum frame size of 64 bytes so that transmitting stations located anywhere in the network will be able to detect any collision before it finishes transmitting a colliding frame. The other popular IEEE standard is the IEEE 802.5 token ring. A token is a frame that is 24 bits only. The token circles around the ring until the station captures it. Stations wishing to transmit must capture the token by just changing a single bit and appending the remaining fields of the frame. Similar to the CSMA-CD, the token ring frame also contains the destination and source address, the error detection field, and starting delimiter. The other fields in the token ring frames pertains to whether the frame is a token or data carrying frame, the presence of the destination and whether it was able to copy the frame, the priority level of the frame, some routing information, and a host of other functions. I hope you have learning so far. We are on the last part of the discussion, which includes the upper layers, the network layer, and the internet protocol. The network layer is concerned with moving packets from one end up to the other end. Since a network may be heterogeneous, the network layer must be able to handle differences as the packet traverses the different networks. Aside from this function, the network layer provides services to the transport layer. These services may be connection-oriented or connectionless. Shortest path routing. The network layer uses a routing algorithm in finding the best path from source to destination. The path may be calculated for every datagram in a connectionless service, or the path may be derived only at the start of connection establishment for connection-oriented service. Algorithms may use different criteria in choosing the best path. A path may be chosen due to its simplicity, or it may be due to its speed and low cost, or maybe it has less hops and fast transmission time, or sometimes stability and robustness is more important than the other criteria. Algorithms may be adaptive, such that a datagram's route changes when there is a change in the traffic or topology, but some are non-adaptive in that the route is assigned statically. Another routing algorithm is the distance vector routing, which is used the internet during its early years. Our next topic is about internet working. Handling differences between incompatible networks can be aided with various internet working devices, the most intelligent of which is the router, which can translate packets from one type of network to another which may have different protocol. This device operates at the network layer. The bridge, which operates in the data link layer, can store and forward data link frames from one LAN to another. Another internetwork device, but one that operates the physical layer, is the repeater, which basically strengthens the signal to minimize signal degradation and lengthens its reach. The next topic is about the Internet Protocol. The Internet Protocol operates at the network layer of the Internet. IP is a connectionless service that provides the basic unit for data transfer. RFC 791 specifies the format of an IP datagram. The IP datagram has four major functions. First, to provide basic unit for data transfer. Next is to provide addressing. Third, to facilitate routing. And last, to perform fragmentation. We are moving now about addressing. IP addresses are classified into 5 types, from Class A to Class E. The Class A address starts at 1.0.0.0 and covers up to 126.255.255.255, while the Class B ranges from 128.0.0.0 up to 191.255.255.255, and Class C covers 192.0.0.0 up to 233.255.255.255. These addresses may represent a host, a network, a broadcast datagram, or a loopback packet. To have an efficient use of an IP address block, subnetting can be employed. The last topic is about subnets. Subnetting is a technique of using portions of the host address in an IP address to serve as an extension of the network address portion. You might be asking how the subnetwork address was derived. This is done by using a subnet mask. For a given IP address, you have to perform an AND operation. With the subnet mask, you'll get the address of the subnetwork.
And that wraps our discussion for today. Thank you for your time and have a nice day.